Namaste everyone. Hope all of you are well. Uh, we have completed thermodynamics, each and every topic. This will be the last video of thermodynamics. Means we have started with system, surrounding, types of system. After that we have gone through state function, pressure, volume, temperature. Then we have introduced a new state function, internal energy. Then we have moved towards the enthalpy. Slowly we have completed all the types of enthalpy, reactions, enthalpy, spontaneous, non-spontaneous, entropy, then Gibbs free energy. And today our topic is Gibbs energy change and equilibrium. As we have seen in the previous video about the Gibbs free energy. I hope all of you have remembered. In the previous video I have informed you the equation, Gibbs equation. Have you remembered? Just pause a video for a second and just write the Gibbs free energy equation. Just pause for a second. I hope you have written, and all of you are very intelligent, no doubt. So after understanding the Gibbs free energy equation, now question is about that whatever the knowledge you are having about the sign convections, where we are putting the positive symbols and negative symbols, exothermic reaction, endothermic reaction, in the spontaneous, non-spontaneous, chemical equilibrium, all the things knowledge I have already given you in the previous video. Now question is about what are the predictions about this negative or positive symbols, what are the predictions about this. So first I have written the prediction of the spontaneity of a chemical change. Now in which direction the chemical is changing, spontaneous, non-spontaneous, or chemical equilibrium. Second one is the prediction of the useful work that could be extracted from it. Extracted from it means you are taking from the system, the work is done by the system. How you can understand the positive and negative symbol, all the convection I have already mentioned to you in the spontaneous and non-spontaneous. Even I have also given you in the entropy, change in entropy, where will be the positive symbol, where will be the negative symbol. Here there is not more greater things. Whatever I am saying you, just you can take a click of this board, and as I am explaining you, you can just see that there is nothing considered free energy changes in irreversible reactions. Now let us examine the free energy changes in reversible reaction. You already know what is reversible and irreversible reactions, right? Reversible under the strict thermodynamics says the special way of carrying out a process such that the system is at all the times in perfect equilibrium with its surrounding. When it is applied to the chemical reaction, the term reversible indicates that the given reaction can proceed either direction simultaneously so that the dynamic equilibrium is settled. This means that the reaction in both the directions should proceed with a decrease in free energy, which seems impossible. It is possible only if at the equilibrium the free energy of the system is minimum. If it is not, then the system would be spontaneously changed to the configuration of lower free energy. Now see what I have said you. As I have said you about the things which gives you the knowledge about the spontaneous and non-spontaneous, how the symbol has been changed, how the system will be in the equilibrium. If we take a reaction A plus B is equal to C plus D, and this chemical reaction is in equilibrium, when the chemical equation will be in the equilibrium, then the change in Gibbs free energy reaction will be equal to 0. Now you will tell me, sir, how is it possible? As there is no means total energy, if we talk about this Gibbs free energy, now here both the systems are equal, no? There is no change. In equilibrium what happens? जो रिएक्टेंट साइड में है वही प्रोडक्ट साइड में होगा. इक्विलिब्रियम रिएक्शन किसको कहते हैं? इस दोनों को तोड़कर ये दोनों बना, इस दोनों को तोड़कर ये. यहाँ पर ये जो सिंबल दिख रहा है, हियर यू आर सीइंग, दिस इज द इक्विलिब्रियम सिंबल, एंड इन दिस इक्विलिब्रियम सिंबल A plus B is equal to C plus D and C plus D is equal to A plus B. There is no change. So there is no change means Gibbs free energy, total energy is equal to 0. So there is no change in Gibbs energy. If it is 0, then you know very well that equation, Gibbs free equation, delta G R plus RT log K is equal to 0. So delta G, standard Gibbs free energy change, is equal to minus RT log K. And one more equation we have just started with the first of thermodynamics. Instead of minus RT, we can write minus 2.303 RT log K. Right? We can write this equation or not? If you are not able to understand, let's begin. First of all, as I have told you, that when the reaction is spontaneous, when the reaction is non-spontaneous, what will be happening in the reversible reaction, irreversible reaction, and this is about the chemical equilibrium. So in the chemical equilibrium, we have just taken an equation, we have just taken A plus B is equal to C plus D. Since it is the chemical equilibrium, so C plus D is also equal to A plus B. Since there is no energy, so here the change in Gibbs free energy, change, not total I am talking about, change in Gibbs free energy is equal to 0. So we have just put the equation as equal to 0. So we have got the change in Gibbs free energy is minus RT log K, and here we have just written minus 2.303 RT log K. Now question is, we also know the equation about the Gibbs free energy change, delta G is equal to H minus T delta S. This is our main equation. This is the main equation of Gibbs free energy, right? Delta Gr is equal to delta H minus T delta S. Here I have just put the subscript, means it is a standard. As a standard means at a fixed temperature and pressure. So here you can see delta G, means here the change in Gibbs free energy reaction is equal to enthalpy reaction, change in enthalpy reaction, minus temperature into change in entropy, which is also equal to minus RT log K. What it is equal to? Minus RT log K. If you have not written this, then please write this thing in your notebook. And for strongly endothermic reaction, the value of enthalpy change may be large and positive. In such a case, the value of K will be much smaller than 1 and the reaction is unlikely to form much product. In case of exothermic reaction, the change in enthalpy reaction is large and negative, and the change in Gibbs free energy is likely to be much larger than 1. We may expect strongly exothermic reaction to have a large K and hence can go to near the completion. So change in Gibbs free energy also depends upon the change in entropy reaction. If the change in the entropy reaction is also taken into the account, then the value of K or extent to the chemical reaction will be affected, which will depending upon the change in entropy is positive or negative. Here there are two equations. If it is possible to obtain the estimate delta G, means that is Gibbs free energy change, from the measurement of entropy change and enthalpy change, and then we can calculate the constant K value at any temperature for economic products, economic yields of the products. And if the K is measured directly in the laboratory, then the value of Gibbs free energy change at any other temperature can be calculated. So this was our main Gibbs energy change and equilibrium. Now we will solve one numerical. There are two numericals in this NCERT. This was the last numerical, that is problem 6.11 and problem 6.12. Here question is calculate the delta G, and that means Gibbs free energy change for the conversion of oxygen to ozone. 3/2O2 gives you O3 at 298 Kelvin if Kp for the conversion is 2.47. Now see, all the things are given. We have to just use the formula delta H minus T delta S. What we are using? Delta H minus T delta S. After using this formula, you can see it is already solved here. So the delta G value is given minus 2.303 RT log K, this one, right? And we are just putting the value of R is 8.314 into joule per Kelvin per mole, and temperature is 298 Kelvin, and log 2.47 into 10 to the power minus 29. So the right answer will be 163 kilojoule per mole. And the last one, 6.12, find out the value of equilibrium constant for the following reaction at 298 Kelvin. Then the 2NH3 plus CO2 gives you NH2CuNH2, that is ammonia, sorry, that is urea. Standard Gibbs free energy change at the given temperature is minus 13.6 kilojoule per mole. So what we are doing, we have to just use this log K formula into delta G by R at 2.303 RT, means here K is equal to delta G upon 2.303 RT. Okay, so you can use this formula also, and you can use this formula also to calculating the numericals value. It's very easy. See, we have to what we have to do. We have to remember the formulas. Whatever the things which are given in the question, first write what the things are given. Then a question should arise in your mind that we should use which formula. What the things are given. Here, see, here if delta G value is given and temperature is given, you can easily calculate the K value, right? Constant value you can calculate or not calculate. These are all the things we are going to read in chemical equilibrium. This is the basic concepts. Whatever the next chapter we are going to study, it gives a little bit hint in the previous chapter. This is the thermodynamics, but in the equilibrium also we are going to study the same things. Since here one chemical equilibrium reaction is given and Gibbs free energy equation is given and Gibbs change energy equation is given. So that's why what happens, the little bit things of the next chapter is already given. So you have to just write all the formula of thermodynamics. Second thing, you have to solve all the questions of numerical means exercise of NCERT. You can download sample papers from the internet and you can solve all this thermodynamics. If you do not have any sample paper, you can message me. I will definitely provide you the sample papers. Second thing, after understanding all the concept, try to make a note of this chapter, because note will help you in exam when you are going to face the competitive examination like IIT, JEE, NEET, JAM and any other examination. That time this note will help you, and the main formula, you know very well, numericals value will be used by the formulas only, right? So as you know the formula from either from the first law of thermodynamics to third law of thermodynamics, Gibbs free energy, spontaneity, all the things means whole chapter formula. You should have a flow chart diagram of whole chapter. After understanding the concept, you can definitely use all these formula. You can solve all the numericals. If you have any doubt in any numericals, then you can comment me, sir, I am not able to solve this doubt. Then definitely I'll help you that how to solve that question. If you have not seen any of my videos, then you can open my channel. After opening my channel, you can see in the thermodynamics series last 10 to 12 videos, you will get all the thermodynamics video. So whole from lecture 1 to lecture 12 means not in which I am not there, that is the secondary thing. That are animated videos in which I am teaching you, that is total 12 lectures are there. So in this total 12 lectures, you have to see each and everything very you can say accurately, precise and accurate. We have studied in the chapter 1. So you have to see everything accurately. You have to use the formulas, you have to write the things, you have to solve the numericals according to that, and definitely it will be very easy to solve all these things. That's all for today. I hope that all of you have understand this thermodynamics chapter. If you have any doubt, any concept you are not able to understand, and please drop it out into the comment box section. That's all for today. Thank you very much. Stay at home, stay safe. Thank you.